Now let's give ourselves some practice doing auxiliary views. And you remember that ASME has a rule that features must be dimensioned in the views where they appear true size and shape. So if you have a part with sloping sides and features on them, you are going to need an auxiliary view in order to be able to dimension them. Think back to the glass box where you put the object inside and unfold the flaps, so you wind up with true orthographic views. If you have an object with an inclined surface, a sloping surface, that's going to be foreshortened in the orthographic views. So what you do is you imagine another flap on your glass box that's parallel to that sloping surface, and you unfold that flap, and now the image that you, in your imagination, traced on that flap is now true size and shape, and now you can dimension it. So these lines are perpendicular and parallel with the edge view of that surface. So you start with the view where that surface appears as an edge. You draw lines perpendicular to that edge, and you draw other lines parallel to that edge, making them the right size for your feature that you're showing. Some, especially old-time drafters, like to think about a fold line and take measurements off a fold line. Now, if you project everything you might see in an auxiliary view, you'll wind up with some other features that are foreshortened, and that might not be helpful. So usually we draw what's called a partial auxiliary view. We do not project all of the features, we only project the one we want to show in the auxiliary view for purposes of dimensioning or something. Here's an example you might remember from last year. Here's a funny looking part and a full auxiliary view in the middle, and you notice that is just not helpful. It has too much going on and it doesn't really communicate what it intends to communicate. Confusing. So if you get that out of there and you just do a partial auxiliary, all we really need to show is the shape of that flange and where the hole is. So now we're better. And here is ASME showing us some partial auxiliary views. You'll notice in this formed sheet metal part at the top, for example, they don't project all the surfaces that one would see. They just project a partial view of the part of the feature that you're interested in. When you have circles on inclined surfaces, like you see here in this auxiliary view, they are foreshortened in the other views and they wind up as ellipses in the other views. So this relates to the part that we're going to draw for this assignment. It looks like this. You're just going to draw a top view, a front view, and a partial auxiliary view, and no dimensions. This is just practice in drawing auxiliary views and ellipses. And it will look like this, your finished view. So here in the top view, you see that those counterbore holes are a series of ellipses, and you notice that the radiused corners become ellipses. And then here is the partial auxiliary view. So you might have to work back and forth between several views. I would start with the profile, the front view, and whatever you are able to fill in of the top view. And you won't be able to do all of it, but you can do this radius nose here. So there's some. And in the front view, you can put in the counterbore hole where it goes. Now you need to lay out those ellipses in the top view. So draw projection lines from this front view. Find where the two edges of the counterbore are and where the center is, and project those lines all the way up into the top view. Now in the top view, those holes are going to be true width. They'll be foreshortened side to side, so they'll be not true thickness, but they will be front to back true width. So you can put in some construction lines for the ends of the ellipses and for the center line of the ellipses. And now in CAD, use the ellipse command to snap to points on those construction line boxes you've made. Now you've got some ellipses. You'll need some more construction lines for the back of the counterbore, and you can copy the big ellipse to make the back of the counterbore and trim it off. You'll need another ellipse for where the hole comes through the counterbore. That's the little one there. And then trim, trim, trim. So now you can go on to the auxiliary view, and for this, project lines from the front view where the surface appears as an edge. Project construction lines. Now, how do you get them perpendicular? I'll tell you what I do, which is probably the stupid way, but I can't remember the right way. To get a line that's perpendicular to this surface, I just come out here in space. I start a line, and using the perpendicular O-snap, I perpendicular snap it to the surface. Now I know it's at the right angle. Now I can move or copy that construction line, knowing that it's at the right angle, and I can move it to where I want it. That's what I do. If you know how to do it the better way, which I think has to do with polar tracking, please let us know. Finally, I want to point out that there are 2 pages of PDFs in your course called Drawing Help Handout that step you through the steps of drawing this drawing, one small step at a time. So make use of that if you would like.